Hello. Hello. Yes. Good afternoon, friends. Welcome to 360 digit MG interview preparation session. I'm Sheila. Today, let's talk about some important questions related to clustering. When we face any interview, we will probably come across these questions, and let's focus on those questions. Let's learn few details on it. All right, quickly let me open the document or me to scribble down to help you out on viewing the questions. All right, let me share my screen. I hope my voice is audible to everyone. Yes. Yes, I hope my voice is audible to everyone. All right, let's start the session. Today, let's learn a little bit about the clustering. As we all know, clustering is something that we perform as a part of our unsupervised learning technique, right? What do we understand by unsupervised learning technique? So to put it in a simpler way, it is a process of grouping similar entities together. That is as clustering, that means it's a process of grouping similar entities together. This is the goal of an unsupervised ML technique, is to find the similarities in the data points and group similar data points together. Okay. To come to the actual question that we want to discuss is like when you face an interview related to unsupervised, this is a unsupervised learning. This is a very common question. How will you define the clusters in a clustering algorithm? Like the number of clusters in a clustering algorithm, right? Anyone? Right. Yes, I'm getting answers. Why it's not known. That's right. Unlabeled data, right? Yes. So when you look at the table, we will not be able to identify how the pattern is in the data, right? We will try and visualize using various graphs and charts. We will try to understand. But for us to categorize it based on certain similarities, we have to perform certain methods. For example, we go about calculating the distance between the two data points, right? Let me write it down for your help. The first question we want to do is, how will you define the number of clusters in a clustering algorithm? Right? Let me increase the font size. Okay. Anyone? Any answers? Right. So we calculate the distance between the data points. That's very good. And how else, like to arrive at some number, like how many out of 500 data points, or like 5,000 data points, how do we arrive at how many clusters that we want to identify and work on? Like how do you classify them? Using dendrogram, yes, that's very good. Right. So let's understand exactly what the question means. So the clustering algorithm is not specified here, right? In the question, you may want to know which method or which algorithm shall we consider in order to arrive at the number of clusters. So this question mainly refers to k-means clustering, where we will first identify the number of clusters and begin with modeling. We first have to define the number of clusters in k-means, and then we arrive at classification or grouping the data points. Right, but before that we have to conduct certain distance metrics and linkage functions to identify. Like K defines as number of clusters. The objective of clustering is to group similar entities in the way that entities within a group are similar to each other, but the groups are different from each other. Right. So if you have like three groups or three clusters, we have to identify how close each data points are within a group. And there should be a very less distance between the data points within the group, and there should be higher distance between the data points of different group. Okay, two different groups. So that is the idea. We will get to the details of it as we progress. Before we come to the k-means, I want to first identify the natural way of doing it using hierarchical clustering. Right? We know what is hierarchical clustering. Can anyone explain that? Any definition? Someone who can? Any idea about that? Right? What is hierarchical clustering? Okay, to answer the first question, we first need to identify that the question is related to k-means. Only in k-means you're going to mention the cluster values ahead and then define the clusters further. Right? You'll classify or group the data points after mentioning the k value in your algorithm. The question is talking about the k-means. Before we go to k-means understanding, let's begin with the basic one. We actually have two types of hierarchical clustering. Let me write it down. Two types. One is agglomerative, and the second one is divisive. Okay. Let's learn a little bit about this. So there are two types of hierarchical. One is agglomerative and second one is divisive. In agglomerative, the data points are clustered using the bottom-up approach. Okay. The data points are clustered using the bottom-up approach. Okay. And the second one is divisive, which is the opposite of that. Top-down approach. Okay, the difference between these two is we begin with one cluster that is one data point. Okay. Here, here we will consider the entire data set as one single cluster. One single cluster. Right? Are you able to follow? Yes. Yes, I'm getting to see some answers. Good. Calculating distance between the data points. Yes, Sanjay. Shankar, using dendrogram. That's good. We use dendrogram in hierarchical clustering. Yes. Then Ipsita, distance among 2 points. Very good. Using elbow scree plot. Yes, we will get to the scree plot soon. Good. Elbow curve graph. Very good. Within sum of squares minimum. And between sum of squares should be maximum. Very good. Similar objects in a group. Correct. Yes. All right. Let's continue. So, what is divisive? It's a top-down approach. Consider entire data set as one single cluster and further divided into subgroups, subclusters. But however, in agglomerative, we are doing the other way around. Begin one data point as a cluster and further find the nearest data point and form a cluster. Okay, it is a step by step, which is a natural ordering, right? This is called as natural ordering, the form of natural ordering. Okay. Right, we have come to know this. Let's understand what are the steps involved in agglomerative. Let's focus on agglomerative clustering. Steps involved in agglomerative. So whenever you answer a specific question, right, when you look at this question, this one question is simple to answer, like how do you arrive by using a k value, by using elbow curve, all that. But when the question is being asked, it is expected that you know so many of them, so many details about what exactly, because they're going to ask you the details of everything. Like when you say how do you arrive at k means, you do certain things like can you not give k value anywhere and get a natural, so that you can mention it is hierarchical clustering. And in hierarchical, what are possible things you can do? You can perform bottom up and top down. What are bottom and top down? You have to mention these details. So with one question, like you will come across the cascading questions related to it. It won't end with one word answer, right? You should be in a position to describe and explain what you mean by that, right? Every time when you face in any interview, you can expect the details being extracted from you in this way. Okay, steps involved in, so when you mention that agglomerative is a bottom up approach, begins with one data point, and then the next question will be like, can you give me steps involved in agglomerative, right? So you be prepared and have a clear understanding as to what are the steps that are involved in building the model for agglomerative approach. Okay, let's start with first question. So in agglomerative, as we discussed, it takes the first data point as the first cluster. So each data point is a cluster by itself. Sorry. Right. So therefore the number of clusters at a start will be k. Of clusters at the start will be k. All right. That means how many data points do you have? If you have 100 data points, the first k value will be 100, representing the number of data points. Okay, now let's come to the next question. Before we come, how it calculates the distance between the two data points, on what basis? When you're writing your Python code on this in clustering or in R, you have to mention the distance metrics. You have to mention which distance metrics you want to follow. Okay, again, there are two types. You may want to write distance metrics. You have Euclidean, you have Manhattan, you have Hamming, etc. You can also have Goers, right? Similarity. Okay, we'll come to each one of them if time permits. Let's know a little bit about Euclidean and first let's know Euclidean, right? Yes, anyone knows about the formula that is used in Euclidean distance? Yes. Good. I'm able to see the answer. Single cluster distance matrix. Merge closest distance data up to we form single cluster. Yes, this is for the dendrogram. You're right. Distance matrix, Euclidean distance. Yes, Neelam. Sanjay, we calculate pairwise distance. Euclidean, yes. Euclidean follows the shortest path. Yes. So again, let's come to a point where how do we calculate the shortest path, shortest distance? Again, there are four different ways in understanding that, right? There is a simple linkage, there is a simple linkage function and complete linkage. We have centroid linkage. We have average distance linkage. Okay, we'll come to individual now. Before we come, let's understand what is Euclidean. It is basically x2 minus x1, right? x2 minus x1 whole square. How do we write that? Here, it's difficult to mention that. Anyway, we know that it is square root of x2 minus x1. X2 minus x1 plus quite sure how each of these are written in Word document. I think it should work. No. Okay, let's not worry about this. Like I get into writing this, it may take longer time, right? I'm trying to look for the formula which is readily available. Yes, yeah. Centroid linkage, average linkage, complete linkage, and simple linkage. Right. Good. Square root of sum of square difference. Yes, that is also correct, Saiteja. You're right. Sanjay, correct. That is also good. Square root of x1 minus x2 whole square plus y1 minus y2 whole square. Good. That is good. Maybe this is good enough for us to understand. This is one of the methods that we follow in order to identify the distance between the data points in order to do the clustering. So in that also we have simple linkage. What is simple linkage? Anyone? What is simple linkage? Minimum distance between the members of two clusters. Simple linkage. What is complete linkage? Farthest 2 points, right? Farthest neighbor. Farthest neighbors between two clusters, right? Okay, next is centroid. What is centroid linkage? Anyone? Anyone? Yes, complete linkage is the maximum distance. That is good, correct. You can call it as farthest distance or the maximum distance between the two data points from different cluster, correct. Next. Yes. So it is the centroid is the centroid, the distance between the centroids of two clusters. Yes, correct. You're right. Sanjay, yes, correct. Shankar, correct. Center of two clusters, correct. Is Ipsita. You're right. It is nothing but the distance between the centroids of two clusters. Centroids of the two, distance between centroids of the two clusters. Then what's next? Average distance linkage. What is average distance linkage? What is average distance linkage? So to simplify, it is the distance between all possible combinations of data or the points between two clusters and take the mean. Okay. So first we will calculate the distance between every point from one cluster to every point of the other cluster, and then we make a we calculate the mean of it, the average of all items. Yes, you're right, Sailaja. You're right. This difference between average of two clusters, see, to be more specific, we have to calculate every data point of cluster 1 to the every data point from the cluster 2, and then calculate the mean across all the distances, right? That is the thing. The distance between all possible combinations of points between the two clusters and take the mean. All possible combinations of data points between the two clusters. And take the mean. Got it? Is it clear? Yes, good. Okay, now let's understand a little bit more about things like, you have your columns, which are sometimes some columns could be categorical and some could be continuous. So there are different ways how you will apply this distance metrics for categorical variables. So for categorical, I mean we convert them into dummy variables of 0 and 1 value using one-hot encoding or dummy values, fast dummy function we have in R and in Python. We convert them into 0 and 1. So once we have 0 and 1, how do we calculate the distance between them? What are the ways? So for a continuous variable, it is very easy to calculate because we will have floating values, right? x1, x2, y1, y2. But for binary, we'll always have 0 and 1. Anyone? Any answers? How we calculate the distance for binary values? Yes. So there are again a few techniques by which you can understand how to calculate the distance. There is something called as let me write distance for binary data. Okay, in this we have binary Euclidean, right? And we have let me write it down. You can explore more. It is not limited to the number of the types of distance metrics that I'm mentioning here. It may not be just 2 or 3. You can do research. There could be many more. Depending on the kind of data and the business problem you have, you can apply it. simple matching, yes, coefficient, and Jacquard's coefficient, right? Am I making sense? Yes, comparative metrics. I'm not quite sure what you mean by comparative. Yes, Gover's distance, Jacquard's index, correct, correct. Okay, in binary, how do we calculate that? Because again, we have to understand when we have a binary problem, we use confusion metrics in which we understand the values of true positive, true negative, and false positive, false negative, right? It is divided into 4 classes, I mean 4 different parameters. In that, to formulate it, we have something called as formula for Euclidean distance. You have b plus c by, I'll explain what is b and c here. E plus b plus c plus d. Sorry, let it be a small letter. Okay. I hope I'm audible. Right. For simple matching, we use a plus d divided by a plus b plus c plus d. This is a simple matching formula, simple matching coefficient formula. In Jacquard's, we pick at least one true negative. Yeah. D. Okay. Square root of b plus c by 4n is correct. Is it correct? I don't think your formula is correct for binary. You may want to recheck your formula. I have mentioned the formula here. Just take a look at it. Yes. When we say A, B, C, D, E, what exactly are these? In binary Euclidean, we are trying to refer it as error. Okay. And in simple matching, we are more focusing on the accuracy of similarities. Okay. And similarly, in Jacquard's, we will see at least one true point, right? We'll consider at least one true positive, and everything and true negative is completely discarded. Let me put a table for your understanding. This actually measures intersection. So going by the formula, you have no and yes as your columns and row as no and yes. Let's do this way. Here you have A, you have B, here you have D, and you have C. What do we mean by this? So this will make sense now. That is Fp plus Fn divided by Dp plus Dn plus Fp plus Fn. All right. I hope I'm not confusing you again. So whenever we have the binary data, this is the formula we have to understand in order to calculate the accuracy. Similarly, we have, so this one will give us error, right? It will show us the error value. Here in simple matching, it shows us the accuracy. What is the accuracy? That is true positive by true negative. Divided by total. Okay, friends, I hope you're not getting confused. Okay, Neelam, I hope I answered your question now with this table, right? Is it confusing? Yes, friends. Similarly, we have Jacquard's coefficient, which primarily talks about the measures of intersection. Okay, this is, as we discussed, d by here we will calculate the true positive divided by true positive plus false negative. All right. For any like disease, no disease, if you want to, understand it that way. Delete. Okay. Is it making sense? So no, yes, no, yes. We'll calculate it that way. So this is how you will calculate for binary data, distance matrix for binary data. We've already understood how Euclidean and Manhattan and Gover's distance, how we are calculating for numeric, right? Here you have done binary. Coming to the next question, top down we have covered this minimum distance, we have covered the simple complete centroid, right? So there is something that we need to understand, like one of you answered this question saying I'll read it out. Within sum of squares should be minimal, between sum of squares should be maximum. Sanjay had answered. That's a very good explanation. That covers a majority of the details of this whole clustering part. Okay, what you said is right. Let's come to that. So let's understand what is elbow curve and why we will consider elbow curve. What is elbow curve? Or scree plot? Right? What is elbow curve? What is scree plot? I would call it as or because it's the same thing. Anyone? Okay, using intersection, I know. What do you mean by that, Sailaja? What is scree plot or elbow curve? What are we trying to do with that? Using elbow curve, what are we trying to derive from that? Anyone? Yes. What is elbow curve? Okay, I got some answers using intersection. Plots k value alongside x and within sum of squares along y axis. Very good, Sanjay. Number of cluster in data set. What is number of cluster in the data set? Elbow curve. Sanjay says where within sum of square value is minimal, the corresponding k value is chosen to be optimal. Formula of checkers. Okay, you're talking about intersection. Okay, got it, Sailaja. Number of clusters to be chosen. Yes, that is correct. So before we come to that, we have to first identify what is dendrogram, right? What do we understand by dendrogram? What do we understand by dendrogram? Yes. What is dendrogram? Yes. So to define it in simple words, it is basically a diagram that represents a tree, right? This diagrammatic representation is used typically in hierarchical clustering. So it helps in understanding how the natural tree progresses, like, bottom up approach, how it is further grouped into classes in a natural ordering. So in order to use this, we have to install the package Dendrogram in our R and Python. We have to import the function and use it. Okay, I think many of you are aware of this particular thing, getting answers. Yes, output of hierarchical clustering diagram, hierarchical relationship between objects. Correct. Yes, correct. So it is basically a diagrammatical representation how each of the data points are grouped together in a diagrammatical representation. And that's where we get to know how each of the data points are first brought together, which are the closest nearest data points, how the first level of clustering has happened. We will get to see that in whenever we have like a huge data set, the dendrogram diagram may not help us because the clustering will take place for a long time, and the diagram won't help us to analyze how the data is being clustered, okay, at the first few levels. So whenever there is a big data set, we probably, for the big dimensions, we don't generally use that. Okay, so for that we go ahead with k-means clustering. In k-means, we will give the k value ahead of it, and then we will perform the clustering. Okay, and once we give the k value ahead, we will try and formulate an elbow curve by which we will come to know what's the best value at which the errors or the variances are reduced. There is no further reduction on the variance. There is no further reduction of, like for example, there are criteria by which you can stop or arrive at a k value. I'll tell you which. So there are certain criteria to identify when you can stop performing further classification, further clustering. So the objective is within the cluster, distance should be 0, right? That one of you has already answered that. Within the clusters should be 0. The distance should be 0. The center of the cluster to another should be more. From one cluster, the center. Okay. Yes, not visible properly. Okay, you're talking about when it is a huge data set. Understood. Yes, you're right. So the objective with k-means is within the cluster there should be less distance, and between the cluster there should not be any similarity, right, between two clusters. That means we can further divide it. We can further divide the data points into further clusters. And no hierarchy, no dendrogram useful for large data sets. Whenever we want to use it for large data sets, k-means clustering is advised. The whole idea with the clustering is to find the homogeneity. Homogeneity means homogeneous groups. Okay, So in elbow curve, we can identify that which k value in the iteration shows the net reduction of variance, that is within sum of squared has to be minimal, right? That's when we will know that particular point at k value, because we have the k values available on the x-axis, and like one of you said, the y-axis is our WSS, right? X-axis is k values. Sorry. Y-axis is our total within sum of squares, right? So what do we understand here? We will always try to find whether the particular k value is giving us the net reduction. At one point, we see that there is a major reduction in the variance. To identify the net reduction of variance using WSS within sum of squares. K value is identified. Okay, is it clear? So elbow curve helps us to identify what is the best possible k value whenever you see there is a net reduction of variance. On the y-axis you will see the change. So there is no further reduction in the variance. That's when you identify that is the best k value. Okay, and sometimes we will get a question like, at what time do you want to stop the iteration? When do you apply the what value you should give for the iteration? When do you want to stop further clustering? There are certain objectives you can use that as a criteria to stop the further clustering. One of them is when each time the pattern gives different centers, then we should concentrate on the within sum of square value. This should be less. Within sum of square is always equals to x minus mu, right? Sum of is the summation of x minus mu whole square. That should be lesser than the WSS. Better the cluster with homogeneity. Okay, is it? There is one important one: when each time the partition gives different centers, right? Then we should concentrate on within sum of squares value. As we know, it should be always less. Okay. Lesser the WSS, better the cluster with homogeneity. Okay, that is one thing I wanted to mention. So there could be a question like, what is the drawback of k-means clustering? Because we have seen that it is helping us out in arriving k value at early stage. We provide the k value first and then we perform certain iterations to identify the best possible k value for homogeneity. But there are some drawbacks with k-means also. What could be that? Anyone can answer? Anyone can answer what is the drawback of k-means? What are the drawbacks of k-means clustering? What are the limitations of the k-means clustering? Difficult to choose k value. Uh, why do you think it is difficult to choose k value? Yes. Yeah, I think Sanjay got the point. Yeah. So every time you run an iteration, the k value keeps changing because with every iteration, the some of the data points might keep switching between the different clusters, and they may enter into infinite loop as well, right? So whenever you give certain iteration and when you see that the data points are constantly switching between two or three clusters and they are not identified as one homogeneous group, then then the local minima will change, right? There will be an error always. This is the main drawback. Okay. For every iteration, the local minima changes, and that's the error. So that is the drawback. Okay. I hope I cleared this. If possible, we'll discuss more on this topic further. We'll see how time permits next time in the next session. Okay, I hope the topics which we discussed today and the questions which we addressed are clear to you all. Yeah. I think we can conclude the session for today. All right, guys, thanks for your time. Thanks for watching.